So today's topic is going to be rapid development with microservices. Um, my name is Noam. I'm a technical lead at Wix.com. I've been working at Wix for the last 4 or 5 years. During those 5 years, I've managed to do a lot of services. I wrote a lot of code because this is what you do at Wix. And I want to share with you some of the tips that I have to make things rapid and move faster. Oh. Let's not now. Okay, but before we start with all the technical stuff, I want to talk to you a little bit about dreams. This is a very custom picture in Kiev because it's very hot in here. So we all have dreams. Like dreams are, we dream big. We want to have better services. We also want to have for a private life. We want to travel places. We want to see places, meet people. For me, one dream that I recently had is to climb a mountain. I climbed a mountain, a very tall one in Africa, and after 5 days and I think it was 5,800 meters, I found myself at the top, and with minus 10 degrees and the enormous headache that I had, I wish I had another dream. But another dream that you can all relate to from seeing all the female and male engineers here is that I want to be a developer. But if I'm dreaming, then I want to be a great developer, because who want to be just a developer? So some of the things that makes a developer a great developer in Wix is that, first of all, the developers are the owners of everything. The DevOps culture dictates that you are in charge. You decide when you deploy the service. You write the code. You escort it to production. And when it breaks down, at 2 a.m. in the morning, you're the one who's waking up and fixing it. Another thing is that great developers are very proud of their craft. It's a form of art. We create something out of nothing, and we care about it. We certainly fight about it among each others, but we care about the system and how it's built and how it's inside, and we want to build the best system. One of the jokes that we had on the way here is that if you give a developer to develop something, he'll try to develop something that developed that something, and not the thing that was asked for him. And then you have to remember that to be great, you have to know that at the end, the code that you write doesn't finish. I hope, at least, doesn't start and finish in your laptop. It's for your customers, and not just users, but customers, because the customers are the one who's deciding if the system will get in the end 10,000 RPM or just like 5 RPMs. And we all want to be in the system that everybody uses. But in order to have that system, we have to give it to the users, and we have to see what they like, what they don't like. So our customers are basically writing the systems for us. If we wanted to have a certain system and our customer says like, okay, no, we don't want the search result in 30 seconds, we want it in 5 milliseconds, then we have to write a system that would work for them. If we don't do that, they will just go to another place. And this is basically the essence of the talk. It's how you want to be effective. You want to have the product that you write in production as soon as possible, experimenting with it. By the way, there is going to be a great talk by Talia about how we experiment stuff in production and how we get the feedback from the users. But to get the feedback from the user, first we have to give it to them. We have to deploy it to production, and we have to see how they react to it. And so we all want to start, everything starts somewhere, so we start a new service, like just a small show of hands. Who's developing right now in a microservice environment? Oh, it's like half of the crowd. And Monolith? Okay. And some people didn't say anything. I guess they don't want to admit. By the way, if you start a microservices, how many people starting a microservices from day 0? Okay, just one. Anyway, if I noticed while developing that actually when you first start a service, and this is why a lot of the services start this way, it's easier to work with a monolith because everything is in the same place. It's easier to test, easier to look at, easier to wonder about. It's so more simple. Everything is small. You have less backward compatibility issue, less, not like none, but it's everything is in the same place. So everything, the deploy is easy. Everything is easy. But we don't like monolith. This is why we started working with microservices. And microservices are actually the greatest choice when you have a very stable environment, not just stable, but bigger environment. Because now, when the code base is big and you have a lot of developers developing to the same code base, that can result in some fights. Also, it's easier to monitor, easier to look at a specific part and test it. But again, it was easier for us to start with a monolith. So today we're going to look at some approaches on how to build a monolith when there is a breakup in the future, how it's going to be not painful. I guess some of the people who started in monoliths are still struggling to go to microservice environment, but that it's very difficult for them because there is a lot of coupling. So we'll look at a little bit of how to at least build a detachable or something, or a monolith where the breakup is in mind from day one. We'll see how to split and when to split and when to resolve and how to resolve some of the issues. And we'll see, and I'll touch a little bit on what happens after we split our services. So let's start. Let's try to build a detachable monolith. When we have like our current server, what it contains our web handlers, our business logic, of course, also persistency or DAO classes that write stuff to our database, and also contain domain objects and our APIs, but also contain, of course, if you heard the keynote, and I guess you're all familiar with tests, because everything needs to be tested to verify that we can continue to press on. And we get a new feature request that happens. We sit in our desk and then our product personnel comes and he tells us, okay, I need some sort of a core service. Maybe I want to send some emails to my customers. Maybe, I don't know, we have a need for a back office system if our internal personnel wants to change some of the things that we don't allow the users. Or maybe some user feature, like we need to put out some more landing pages to able to advertise our sites or our user sites. So in this example, I'm just going to use an ambiguous service. We'll call it stores. And let's start a new module. Like if we want to build our back office right now, what is a back office supposed to have? Well, basically whatever a server contains. It contains REST APIs and web handlers. It contains some business logics and DAOs, same as any service. But we want to put it in a new separate module. So now our server looks like our main server, which was stores, and the second one would be stores back office. It's two different modules, and everything that's related to the back office is going to be inside of the module for the back office, and everything that's related to whatever we have so far is going to sit in stores. So we started and we implemented everything and we deployed to production and everything is good. But the first pitfall in our detachable monolith journey is that we tend to depend on stuff. Some class from our stores will start to connect directly to the back office or vice versa. So that would cause some coupling between those modules, but we want to create it as a detachable one. So if our server modules or our stores server is depending on our back office or the other way around, it's gonna cause problems later on. We can never actually rip out that module very fast. So how do we resolve that? First, we'll do like initial refactoring. We'll take our current store server and we'll split it to two different parts. will take the store's core and everything that was before, which was all the business logic and the DAO and the web handlers, and we put all the code, including the tests, in one module, which we'll call it core, which is a default name, but we can come up. Well, naming is a difficult problem that I don't think I can cover in this talk. The second one will be our wiring, the server module. The server module will only contain wiring for the server. If we firing up a Jetty server or whatever server, the web XML, if we have one, or if we do it in code, it's going to sit here. If we start and do new for all of the components and objects, we're going to do this in this composition layer. So the store server will just drive up everything and connect everything. And of course, and if we connect stuff, we need to cover it by integration and automated tests that will verify that after we did this refactoring, the server actually starts. This is, by the way, the first test that was ever born, because people were writing code and everything was passing locally, but when you tried it in production, it just doesn't start because you forgot something. So this would be the first step in our journey. The second one is now we have dependencies. Core and Backoffice. Backoffice is talking directly to core because he wants to get some of that information. So how do we resolve that problem? The easiest solution, which is, of course, it's easy because everything is in the same place, is to extract a different module. We'll call it API, and we'll put the interface in it. The implementation will still sit in our core server, but then Backoffice will be indirectly dependent on that same class. So now, once we finish that part of our refactoring, once we finish that, we can actually remove the dependency. Core doesn't need to know Backoffice anymore, and Backoffice doesn't need to know core anymore. They're dependent, but indirectly. Server, of course, knows everything, but still, Backoffice and core are now individual modules, and we can remove the dependency. But just interfaces is not enough, because we also have domain objects. Our classes, I hope, doesn't return map of string and string, and it also contains some domain objects. In our example, let's say that a user is one of the return values that's being returned from Backoffice. So how do we, is that also an API? Actually, domain objects are even the toughest API issues that we can resolve. These are the backward compatibility issue that we keep experiencing. And if we want to extract an interface, we also have to extract its domain. The domain is actually also an API. But if we take the entire object that we have for our internal use, which was very easy because everything is in code, and we put in API, for example, in user, we have maybe Backoffice only needs the user ID, it doesn't need anything else, and user contains username and address and a lot more other properties. We don't want to overshare it, because later on, it would be difficult for us to change it further down the line, and also people in Backoffice, it's going to be harder for us to understand what the API is. So we want to share only what we must. So if core is using Backoffice and it needs only user ID from user, we're going to extract to the API a new object that is only the user ID. So we want to keep the interfaces as small as possible, because small is actually simpler later on. And if you notice, by removing dependency, it exposes a lot of things in the modules. And this is where this quote comes in, because good fences make good neighbors. By keeping the modules separated, it's going to be easier for us, first of all, to understand and design our API in a smarter way. But it also shows us where the connections are going and what exactly is being shared from one module to another. Another issue is persistency, because if our modules are independent but still use the same database, it's going to be a problem later on. Actually, splitting up databases is a far more complex problem. anybody ever tried to split a database with 2 million records? It's not a pleasant experience, and you have to migrate a lot of stuff, and you still have to do it where everybody's working with the system. So the problem is when you put just one database, like there are like two main issues that we consider when we look at microservices and monolith, is that we can have dual writes to the same table from multiple services, which will be very difficult later on. But the biggest problem that we'll also try to understand how to tackle, is that developers are, well, we all care about performance, so they're always going to try to join those domains together in a single select. That problem is a very difficult one to later on split when when we want to move to a microservice environment. So we'll start with the easiest problem, like we'll start by splitting up the multiple use, the read and writes to the same database. Like core was writing directly to the database, and Backoffice was consuming that data. So in order for us to extract or to break that dependency, what we'll do is we'll create some core client, and in the core client, which is, by the way, an API the same way it was before, we'll have Backoffice use that core client, and then he will get all the data that it has as before, but he won't touch it directly. This will save us later on problems, like, for example, when we have microservices depend on another schema, then one service could not change that database. Like the schema was part of the contract it has with another API, with another module, and that caused a lot of problems. So by splitting it early on and giving each module its own database, it will, first of all, it will be simpler for us to split it later on, but it will also allow us to avoid the biggest difficult problem, which is join between tables. As you know, if developers has the possibility to join, they will probably join it. And if they joined it, so what do they do now? What do we do now with our monolith? So the first thing is to consider every join as a server concern. Write it in the code. If you have joined between two data sources, just retrieve the data from one side and retrieve the data from the other side and join it in code. This is going to solve that problem, that now you can go through the API of that specific module, take the data and merge it in code. And apparently, and the first question that's being raised when you tell that to people, they go like, okay, but what about performance? Join is faster, and I want the data to flow faster. So there are various solutions for that, and it depends on how performance is important for you. Like, for example, you can do it what I said before. You can do synchronous joins, even with microservices or not microservices. You retrieve data from one source and the other source, and you merge it in code. That if the system is remote, it doesn't matter. You still do it in the code, and everything works. But then someone tells you, like, okay, it's not fast enough. I want it to be faster. So you can put a local copy. We have an infra that actually takes data from one system and the other and updates it every 5 minutes or every time that you want to say that you state. That local copy, by pulling the data, will be enough and will be very performing. But if the data is very big, then comes more of event sourcing architecture, where you update the local copy and it's going to be updated in a very minimal way. So we can resolve those problems later on. So we're better off, at least at first, not couple those systems in our databases. The final tip that I can have about the persistency is one of the things that I learned, well, I would say in the good way, because I realized how it simplifies things. Is that, first of all, if you need to write persistency of some domain, in the early days, everything changes a lot. So if you automatically write them into a persistency, let's look at an example. We have a product, and our product person tells us, okay, it needs this and that fields. Also tells us that it needs title. So we add a title, we add the column, we add everything. 3 days later, once they see the product, they go like, okay, title is not good enough. So we want a short title and a long title, because depending on the screen, we want to display it on another thing. So we have to go back to the database. Those changes take time and more time. And if you have like a system team, then you have to open a ticket, and it will take even more time. So when the domain is still young and requirements keep coming, you can write it in memory. You can write the test, you can write everything to make sure that the data is behaving the same way that you want it to behave, but in memory. And if the product people goes like, okay, we need some data, then you actually load it up with a little bit of data to make people run work with it. Then the client can integrate with it, product people can look at it and play with it. And once they finish, they probably want to say, okay, so we're done, but let's try to wait just a little bit longer and try to persist it just locally on a file or something like that, or a global location. When you do that, we'll give them a little bit more time to play with the product and see if they need more and more requirements. And when the domain is stable, when they stopped adding fields, changing fields, or doing some weird result, then we can start in creating a database. I'm not saying, by the way, with this step that you can that you need to go to production in an in-memory database. Although that's possible as well, if you're opening it only to internal users. But again, when you'll hit production, it will be on a database. But at least try to hold on to that and wait, because if to deploy something which is implemented in memory, it takes you about like 5 minutes. To deploy and change stuff with the backward compatibility and remove and add columns of a database, that will take you half a day at least. So if you want to move fast, you want to start this way, because it's going to help you to press on. Okay, so we went so far and we built our modules. They're detached, they're detachable, and they don't share the same data. Everything is shared using the API. And if we continue this way, we'll have a monolith, which is, some people say it's bad, but let's see, when do we split it? Because if we don't split it, then we're stuck with the monolith. What am I talking about? What can trigger a split? Why would we want to extract some module from the company? I put out some reasons that I know, but there are many other reasons. And reasons go like the easiest one would be scale. Some of the modules, some of the service that gets apparently you have a renderer module, and the renderer module starts to get a lot more traffic, and you want it to be able to deploy it to, instead of 1 server or 2 servers, you want to deploy it to 100 servers. So you don't want to take all of the machine, all of the code and put it. You just want to have this tiny part of the system being deployed to a lot more servers. Or maybe there is one of the services that you built is very important to the organization. Let's say, for example, some payment or some account management. So you wanted that account to be stable while other people play around with the system and don't kill that important service. Other reason would be that you developed, let's say, an email service, and another team comes and says, okay, I want to send emails as well. Maybe I want to use your system. I don't know. I don't want to rewrite it. So maybe we want to generate a generic service that will send an email for us. And even organization reasons, like one member of the team is moving to another team and is taking the email service with him. So we're not going to allow him to continue and update the repo from another team. We're going to move that service to him with the code. And of course, some of the features get to those days where we just want to put them aside and let them die slowly. So if it's in the end of life of the process, then we want to extract it, put it somewhere, and have nobody touch it, because we want the user who's using it already to suffer. We just want him to gradually stop using it. So I put out like 5 reasons here, but what happens if none of them happens? Well, If none of them happens, then there is no need to split anything. You only need to split it if there is a reason. And that reason will come up, or maybe it would never come up. The reason that it will never come up, maybe your service doesn't get the proper customer acceptance. People don't like it that much. It doesn't get that scale. It doesn't get a lot of traffic, so you don't want to split it. So that's okay too, because in this case, we can just leave the service as is. Everything is working. And in the future, if something will change and those events will happen, then we can split it later on. So how do we split? Okay, we talked a lot about splitting and how to build stuff that are more splittable. But how do we do that? Like, for example, our server right now looks like this. We have the API, we have the core and back office module, and of course the server harness there for everything that starts the server up. So let's say our back office system is very good and we want to extract it out of the service because it's no longer supposed to be there. So how do we split it? Is it difficult? Well, it's not very difficult because there is no dependencies. So we can actually take that specific module, copy it outside, copy all the server harness and the integration test that brings them up, and we have a new service that does the back office. But wait, it's not that simple, because now we have the old service and we have the back office wants to talk to the store manager. So how do we do that? We go to the back office and we build a remote client. That remote client will have to talk to the store server and get that interface, get the data that it used to get, where it had in the module, in the API module. But how do we know the contract? Well, it's very easy. The APIs is specifically defined in the API module, so we know exactly what we're sharing. We know exactly which object we're sharing. Like, for example, at Wix, we had an old, our own RPC framework that allows us to use operation as a function. So we take an interface and automatically it access it remotely. But now we're in the process of moving to gRPC. So there are a lot of frameworks that allows you to talk between servers. But the difficult part is not the talking. The difficult part is knowing what is the API. And we figured that out on the first stage when we extracted stuff to the API module. Once we're finished with splitting stuff and moving forward, we have to remember that we can move fast as a team. I can move fast as an individual, but I'm not alone in the company. It's a big company, and there are a lot of people who uses the services that I provide. If it's an email service or a push notification service, or even a lot of types of services. And if I'm moving fast, but all of the other teams are moving slow, it's not good enough because we all have to move fast. And we're as fast as our slowest team. If one team is blocking the delivery chain, then we're not fast. So it doesn't help to be fast alone. You have to run together. So what do we do to resolve that? Like, at first, the first simplest thing is actually to provide some sort of a sort of documentation. We use GitHub to give out. This is actually a documentation from one of the libraries that I supply, and it bootstraps people into the service. They know what to import, how it works, what to expect from it. But it's just documentation in GitHub. It's not going to do. It's going to allow people to just read stuff and know how to copy paste some of that documentation. But it's not good enough. So the thing is that we have a contract to this service, so we build up a contract test that would enforce that contract would not change. If someone is using my service, I have to be able to sustain the same API. If I'm going to break it, it's going to be a big problem for him, and then it's going to be a big problem for me. So first I'm going to protect it by automated tests, and later on I'll supply a test kit. To know a little bit more about test kits, we have a talk by Max tomorrow, right? Today, I'm sorry. So don't mess it up. He miss it because he will tell you more about how we build test kits. But test kits in general are some sort of an integration code that will allow you to integrate with the service in the testing area and not in production, like we don't like to do. So once you have the test kit and once you have the contract test in place, you have the integration code. And the only tip is what the size of integration test of the integration code that you have between your service and other service. It should be smaller than this. And if it's 5 lines, it should be 4. And if it's 5 words, it should be 4 words. And the only you want to make people as easy to use your service as possible. And if you have to work like 3 more days to reduce the integration code to even less and less, it's worth it, because your time, it's going to be 5 days, but those 5 days multiplied by 50 teams, sometimes that takes a lot of time on the organization, and sometimes it actually prevents people from using your service. And this is almost the last slide, because when you're working in microservices and you build a lot of services, you need to pay attention to the common patterns that arises. Because one microservice is using a database, a MySQL one, and it needs a testing, and another one, and then another one, and then another one. So those common patterns will result with a framework in the end. So other teams who wants to use a database will have everything in place. So if you notice those patterns and you start extracting libraries and common code outside, you'll build your backbone. And that backbone will allow everybody to move faster. So libraries and services as libraries is very important when it comes to moving fast as an organization and not as an individual team. And we'll conclude with that. The takeaways that I want you to have once we're done with this presentation is, first of all, build a detachable monolith in mind. It's beware of dependencies in the code and in the database especially. When an event happens that makes you want to extract some of the module out of it, do it. But if it doesn't, just leave it as is until some of those events happen. You're as fast as your slowest team, because the team, if all of the team are moving fast, then the organization moving fast, and this is the important part. And the common the patterns will result a good and sustainable backbone that will help all of us to move together. And by this, I'm concluded. And if anybody want to ask questions, and if not, I'm walking around here, so you can feel free to
Raise
come.
your hand if you want to ask questions.
We have time?
Yes, we have 8 minutes.
Oh, 8 minutes before time.
Anyone?
Oh, so I have one question.
Thanks. Can you hear me?
Yes, I can hear you.
Thanks for my presentation. The question I have is, how are you gonna manage the versions of frameworks in different services?
Oh, it's a great question, actually. It's a difficult part. For example, one of the issues that we hit these days is we always work in the latest snapshot. So every changes that was introduced to the framework was building the entire all of the code in the system. The problem that result was that our build system, they couldn't handle it, because every change in the framework changed everything, and the build graph was very, very big. So today, like currently, we release the snapshot. We release the framework version every, let's say, day or two to reduce the overhaul on the build system. And right now we're in the process of actually moving to a smarter build system, Bazel, which will allow us to build to have everything built very in a smarter way. But the problem that you're mentioning is a very big problem when it comes to build times. Any other questions?
I have a question. And how do you maintain code consistent across different environments? Like stage, dev, prod?
Actually, staging environment never worked for me. I never heard of anyone who has managed to tackle that problem. The way that we handle it, I think, currently is with experimentation. So if you have a new feature and you want to deploy it to production, you deploy it, but it's guarded by Petri, which we'll talk about later on tomorrow. And by that, you can deploy it automatically to production and test it in production and have just specific people access it. So we can limit it to just the developer or just our company users, or maybe we open it gradually to some geos and see how it behaves. But staging environment, once you go to a certain stage, you have to redeploy it like every second, because if you have more than, let's say, 6 services that people keep adding code to them, every time you want to test something, you have to pull all of it, start all of the services from the beginning, and just the deploy process takes longer than the system gets updated. So the only way that I could find that works is with experimentation in production.
Thanks.
Okay, so thank you for your time.